Hello again, scholars. Good to be back with you. And today I want to go over a little bit on how to add vectors. Now this is something that comes up a lot. I'm a professor, that's my day job. So it's common for people like me to be drawing pictures on boards for people like you, and we'll have arrows and lines going all over the place. And we'll say something like, we'll add all these vectors up and here's what comes out. Okay, well, what does that mean? Well, let's start maybe by thinking of a situation in which you would want to add vectors. All right. Now vectors show up everywhere. There's just think of it as a multi-dimensional equivalent of a number. A number has magnitude, but it doesn't have direction. A vector has magnitude and direction. It points somewhere. That's a vector. It points somewhere, and it points somewhere with a length. Okay. So this is a model of a MiG-3, which is kind of an obscure plane anymore. And I got this from my friend Gosdom. She was very nice and gave this to me. So if I've got this little airplane here, I'm going to get out of the sunlight, there we go, and I've got a little propeller on the front, engine pointing that way, so the engine makes a thrust that way, the propeller does, and the wings make a force upwards, and the weight goes downwards. Well, those are forces in 3 dimensions. If the weight downwards and the force upwards cancel out, that is, if the 2 vectors sum to 0, then the only force I get left is a force that direction, and the plane flies level. If the force upward is greater than the force downward and there's a force this direction, I get a vector sum that goes that way, and the plane goes forward while climbing. So let's maybe draw a picture of that. Okay, if I have, I'll do this in blue perhaps. Okay, I don't, there's a very bad MiG-3, how's that? There's a really bad MiG-3. Okay, weight goes down, lift goes up, and the thrust goes that way. All right? Now, if lift and weight cancel each other out, the sum total of those is 0 and you only have thrust. But what if lift is greater than weight? They don't cancel out, and the vector sum of those forces is that. Okay. That's an example of adding vectors. Okay, so in concept, that's how you do it. Well, mathematically, what are we talking about here? The reason I'm hiding over on that side of the board here is I've got a little bit of sunlight on me here, and I can't figure out how to block that out, so I'm trying to stay out of it as I talk. Let's try this again. Okay, now, do we understand that a vector has magnitude and direction? It's just a number that points somewhere, if you want to think about it that way. Well, let's say I have 2 vectors, okay? I have one that goes this way, and I'll call that vector A, and this one points that way, and I'll call that vector B. Those are 2 vectors. So that might be the net lift on the plane, and this might be the thrust of the propeller, okay? Now, if you're into electronics, signal processing, acoustics, anything like that, there's going to be vectors. Weather, vectors out the wazoo. Because if you look at how wind blows, wind is a vector. It's got magnitude and direction. So if it makes a circle, sometimes it makes like a storm or a hurricane. So I've got A and B here. Now, how do I add those together? Well, there's 3 ways to do this. I'm going to go through all 3 of them. One is you can do this. Okay? Because these have a magnitude and a direction, I'm going to give these the same magnitude. I'm going to say that, shouldn't do it that way. The magnitude of B equals 1, and the magnitude of A equals 1. Okay? And they have directions. This one's pointing horizontal, this one's pointing vertical. So all you really got to do in this case is you can treat them as elements of a rectangle and find the hypotenuse here. And so that's, okay, there it is. That's A plus B. Now there's one thing I want to change here. I'm calling this A and I'm calling this B, and that's okay as far as it goes. But if you look in textbooks and things, they don't just call that, that's not just a scalar. If there's no identifier there, you think of that as a scalar. There's this little thing, this little hat that you'll see people put on it, okay? That's called a caret, C-A-R-E-T. That is not the orange thing that you eat, and it is not the weight of a diamond. That's actually its name, and it's a character, okay? So there's how we identify vectors, and there's how one way to add them. That's one way. Another way, let's see if I can do this here, stay out of the sun. Yeah, I guess this will work. You can do what they call nose to tail, okay? And if you want to see how to add two vectors, you simply stick one on the end of the other one. This is A, and I'm going to take B and I'm going to place it right there. Okay. Okay, so this is method number 1. I'll call this method number 2, I guess. So I've got A pointing that way, and when I get to the end of A, I'm going to append B onto it. Just stick it on the end. So there's A, and there's B. Another magnitude, another direction. And I can keep stacking these up if I want to. And then find the connecting line between the starting point and your ending point. Okay? That is A plus B. Okay? And what you'll get from this is you'll get a magnitude and a direction. Vectors have magnitude and direction. So you have to define your direction with respect to something. It's common to do something like that. So magnitude of this one, we'll use Pythagorean theorem. And we'll get the square root of 2 on this one, so these both have a magnitude of 1. And theta, okay, is the inverse tangent of delta y over delta x. Okay, well in this case both of them are 1. So theta is 45 degrees. So there's 2 ways to do it. Now, there's 2 others actually. So if we go through this. All right, number 3. Okay, method number 3. There we go. We're going to use what's called unit vectors. Alrighty. Now, the way we do this is we'll define a couple of what are called unit vectors. They have a magnitude of 1. So multiplying a number by a unit vector does not change its magnitude, but it does change its direction. Okay. So I looks like this. Okay, it has a magnitude of 1, and it's horizontal. Okay, that's the, okay, now this is not I, the square root of minus 1. This is I, the unit vector. There's only 26 letters in the Latin alphabet. We have to recycle a few. This is one of them, okay? So that's I, and the other one is J. Not too surprising there. And it also has a magnitude of 1. And it's vertical. Now you can carry this out as much as you want. If you want to work in 3 dimensions, K is the next unit vector, and it points along the z-axis. So this points along the x-axis, y-axis, and K, if you wanted to use it, would point on the z-axis. So this right here, what I had before, that would be 1I, where I, again, I is the unit vector. It is not the square root of minus 1 here, right? B is 1J, okay? And let's call this C, okay? I'll get my head out of your way here in a second. Okay, that's terrible. So C is A plus B, so it's 1I plus 1J. Now if you want to do something a little more complicated, if you wanted to have something that was like 2I plus 1J, you could. It would come out 2I plus 1J, and you could figure out the magnitude and phase angle that way. So that's number 3, unit vectors. Last one, okay, save this one for last, is you can in the correct circumstance, you can't just be doing this casually, but as long as you're applying this correctly, you can use complex numbers to describe vectors. Okay, you can do this if you want. If that's real and that's imaginary, oops, try that again. Imaginary, I could go out this way, and that point right there would be 1 plus 1i. In this case, where I is the square root of minus 1. Now I is not the unit vector now. It really is the complex number square root of minus 1. So this is the other way you can do this. Now let's do one more example here. I'm not going to go on too far into this because I suspect most of you aren't going to want to do it this way. But if you see it this way, that's completely kosher. Let's do this. Let's add these two vectors. I'll call that A. Okay. Let's add those two. Well, what I can do here is I can go over 2, up 1. That is going to be the square root of 2 squared plus 1 squared. Okay, and I'll call that A, B, C, magnitude of C anyway, is going to be the square root of 2 squared plus 1 squared equals the square root of 5. All right, and so magnitude of C is 2.236, I think. Yeah, 2.236. And theta is just the inverse tangent of 1 over 2. Okay? So there you go, folks. That's how you add vectors. Okay, we found 4 ways to do it now. Okay? We can make a rectangle, we can go nose to tail, we can use unit vectors, or we can use complex numbers. Those are all the same idea. They are just different manifestations of the same idea. So there you go. There's an example for you, a simple one, admittedly. Hope this helps, and I'll talk to you next time.